So today I'll take you from static twins to live automated operations in any browser. And specifically, we'll be talking about AI agents for digital twins in the metaverse. As you probably heard, Jensen Huang from NVIDIA said, virtual first, then physical. And this is the norm now. Cities and organizations need digital first infrastructure. But there's a problem. The current digital infrastructure platforms are limited, they're complex, and they operate in silos, which makes collaboration, planning, and real-time data integration fragmented and inefficient, if even working. We have a solution at Bizztech. We provide a browser-based metaverse platform that brings smart spaces to life. Built-in automation with our agentic AI HAL 8122, he listens to live data, test options, and execute approved actions. That makes the platform flexible by opening the door to multiple use cases and ideas, simple, easy to use from any device, unifying, breaking down the silos, and persistent because it's continuous, and we use agentic AI for that. So now let's talk about the AI agent and the role of the metaverse. What's an AI agent? Agentic AI agents, as we see, are real-time agents that are intelligent, continuous, and they are digital entities. They are capable of multiple tasks, like managing tasks, monitoring, learning, acting, optimizing, simulating, etc. They are little helpers that are here to help the organization, the cities, to bring data into actionable prediction, decisions, and interactions. On the other hand, the metaverse, it's an immersive collaborative environment with the digital twins at the heart as a backbone, and AI brings adaptability. We also bring the urban and societal scale. Together with all these components, that brings resilience, inclusivity, foresight, and large-scale collaboration. When you add the agentic AI's agent and the metaverse, we create value for cities and citizens. Let's talk now about a project that we've been working on with the city of Peachtree Corners in the US. So Peachtree Corners is one of the smart cities, a pioneer smart city in the US, with world-connected infrastructure and 5G. At the heart of the city is a laboratory called Curiosity Lab, which is a test bed for smart mobility, connected infrastructure, autonomous vehicle. We work with Peachtree Corners and Curiosity Lab to create photorealistic digital twin of the city's downtown, the city hall, the town green, and we bring all of this in our metaverse platform with our AI agent, with the additional use of live sensor feeds, traffic analytics data, and weather data. We partnered with companies like Atlas for visualization, S3 for GIS, Circuit Meter for utility data. The goal of this project was to create an urban metaverse that is set to redefine how the city manages its infrastructure, enhance public safety, and make data-driven decisions. I have a small video that I can show you if I have time. So this video is a showcase, a demo of the Curiosity Lab building that we've scanned. So you can interact with your surrounding. You set me as an avatar. So these are the different views that you can have from the Curiosity Lab metaverse platform. You can see the different views. You can either have a bird's eye view or go directly as an avatar within the different rooms. So this is showing that there's a live temperature heat map that basically takes the sensor data and gives you any information about how the environment is acting. Sorry about the sound. Okay, so sorry, a bit too fast. So you saw the video of the Curiosity Lab platform, and from that we applied some agentic AI. Let's see what we did exactly. So we worked with the city to define the main goals that they wanted to get from the platform. It was in terms of traffic management, energy optimization and resilience, urban planning, incident response, and learning. In terms of traffic management, the agentic AI was able to analyze and visualize the traffic state and avoid any bottleneck, any issues that they can see. Then they will reroute the citizens to a different place and also help with traffic lights timing. In terms of energy optimization, by analyzing the different energy status in the buildings, we were able to provide information about the different heat maps with heat maps in the buildings. So the city, we use AI agent for traffic management, energy optimization, and resilience, urban planning, incident response, and also to always be learning. In terms of energy optimization, we wanted to make sure that the city had all the information about how the different city energy were consumed and provide guidance in that. Then urban planning. So they were able to test and rehearse the different expansion plans and also the autonomous vehicle expansion plans. In terms of incident response, by using AI agents, they were able to dynamically rehearse emergency protocols and simulate hazards. And by that way, they were able to adapt dynamically if it's in real time. And in terms of always learning, the combination of generative AI and agentic AI was not only able to simulate, but also predict some outcomes and autonomously adapt to scenarios. In terms of outcomes and learnings, so there was smart mobility, energy resilience, preparedness, public safety, and collaboration practice. What does that mean? That means for smart mobility, the city were able to adaptive the signal timing and reduce it in terms of congestion and peak hours. For the energy resilience, the agent balanced the EV charge demand to avoid grid stress. For the preparedness, the simulation revealed vulnerabilities to extreme weather, informing contingency plans. Regarding public safety, the predictive analysis flagged hazards and bottlenecks before they even escalated. Collaboration in practice, that means that the city officials were able, with stakeholders, to use the immersive environment and that foster dialogue within the same people, with them. So there was an aspect that was very important for the city, which is the human dimension. And in the project, we wanted to make sure that the humans were always overriding the AI. So the AI, the human-centered guides, our AI agent and digital twins were deployed, ensuring transparent insight for city officials. And we did that by three things. First, trust and transparency. We make sure that the AI was explainable and that gave stakeholder confidence. In terms of collaboration, by having city officials, the industry, the researchers, and even the community within the environment, it was easy for them to understand everybody's point of view. And the collaboration made the human dimension very more powerful. Human in the loop, always supporting AI. AI will support human, and the human will always decide, always have the last word. So that means that in critical missions, our AI is here to support, not just to override the humans. So to see the key learnings and takeaways, what do we learn with this project? In these troubled times about AI, trust in AI can be there. We can trust AI as long as there's explainable and transparent decision, as long as people know exactly what the AI is being used for. Interoperability, the system and data must connect seamlessly. Here we connected not only our AI, but the circuit metadata, the IoT data from S3, and also the GIS data, and all the data from the IoT sensors. That means that there was no silos. Human in the loop, the AI supports, but people decide. As I was saying, AI is here to support people by bringing foresight, predictability, but people always decide. The AI agents make digital twins adaptive and intelligent. What do we mean by that? I mean that we take static twins that are complicated, complex, and hard to read, how to use, to intelligent systems, ecosystems that help make decisions. The metaverse turns them into collaborative ecosystem by bringing into this environment all the different stakeholders from city officials, industries, utility companies, and the community. And Curiosity Lab now shows that this model can be scalable for smart cities, and we want to use it as a blueprint for other development. So in conclusion, AI agents for digital twins in the metaverse are not just here to optimize systems, but they're helping to shape the future of participatory, resilient, and sustainable cities. And we can have an outlook for the future who could be generative AI and agentic AI. As they evolved, digital twins will become increasingly autonomous, but governance and human oversight will remain critical. And this is one of the things that we at Bizztech want to make sure that happens, having the human-centered approach for every project. And this is it.
So the first one is that scan or Gaussian splat, or did you model it after?
So it's we use LiDAR scanning and Gaussian splatting, so it's both technology. We use Unreal Engine, but it's part of Gaussian splatting with scanning. Both technologies are used.
Thank you. Next question is, how live is the model of the Curiosity Lab? If a light falls, will it show on the model? If the engine is moved, will it show? Will it show me if a colleague is in the office?
So how live is, yes, so let me reread the question. How live is the model? If the furniture move, will it show? if there's sensors on the furniture, I will probably show. Basically, a digital twin, we take any data as we scan the environment. Obviously, we scan everything. If there's any sensors on any object or any building, any part of the building, yes, we'll get the information for that. As if it's the furniture move. To be honest, I don't know. I can ask the question and go back to you. But if it's not live data, we can't really see them moving.
Sounds good. Depends on the sensors. That sounds good. So does the AI explain itself, or do you have to do analysis?
So the way we train our AI, we can ask him to explain why he's making these decisions. Is that okay for the answer? Or do you want me to be more elaborate?
No, that's I think that answers that. And who created the AI agent, and what models were deployed?
So we have our own machine learning systems, and we also have our large language models. So it's us, and we also use open standards as well. It's a combination of open standards, our machine learning, and if we work with cities, organizations they don't want to go use open standards, we can use their own machine learning and LLMs.
Very good, thank you. You've partly answered this question already in the first question we asked, but just in case there's anything else you wanted to add, could you share with us how the indoor 3D model was created?
Same, by scanning. So we scan the environment, we use SGrid, and the SGrid is also capable to directly get the data into Unreal. So all the Gaussian splatting is integrated.
Perfect. Question here, where was the project delivered? Was it city, and is it in the downtown area, etc.? And is there a case study we can refer to in the future?
So the city the project is an ongoing project with the city of Peachtree Corners, which is close to Atlanta. So we started with the city hall, the town green, and a third building. So we started by incrementally by adding pieces by piece, depending on the issues that the challenges that the city has and want to solve with the metaverse.
Perfect. Thank you.
And the case study will come a bit later when it's ready to come.
Thank you. Our penultimate question, metaverse and digital twins are certainly complementary, but how agentic AI is implemented in the virtual space? But how is agentic AI implemented in the virtual space and validated? For example, how do you test traffic flows?
Okay, great question. So the way we implement the AI agent, it's you see it as the ears, the eyes of the city that never sleep. And basically, the agentic AI, this is part of some of the features that we have in our platform. So depending on what the project requires, we can add the agentic AI or just have normal AI, like generative AI. And the way we test it is obviously because we have sensors that are, we take the sensors data from traffic lights, from maybe the grid, from different information that the city gave us. From this data, the AI will compile it, will analyze it, and then give prediction, give guidance. And because the AI is capable of reading all the open standard data or all the data that the city has been giving us, that's what we can see, we can interpret, and AI can do that as well. But maybe there's a traffic jam coming, or maybe there's a problem with the traffic light because the AI can see based on the sensors.
Very good. Thank you very much. And our final question we have here is, will the webinar be recorded and shared? And so that the question asker can share with their colleagues in other digital twin sectors. So to answer that question, yes, the sessions are recorded and they will be uploaded to the Digital Twin Hub alongside all the other recordings of the Gemini calls that we have historically, where you can, of course, watch back and continue the conversation from there. So we have had actually one more question and then we'll bring it to a close. Is how scalable is this project and can we apply it to other digital twins?
Absolutely. So This is totally scalable. That's why we started with 3 different places: the city downtown, the Green, and the city hall. But we can scale it as big as you want. So the metaverse is a digital environment. So we can have digital twins within the digital twins within the metaverse. And what we do is we make it interoperable by adding systems, tasks together within the digital twins. So that's the goal, to have an ultimate digital twin of maybe a whole country one day. Who knows? We're already doing that with Ukraineverse, actually. We have a project called Ukraineverse where we already starting building digital twins of the country by adding these small digital twins from different places in the city, in the town, in the country.